A short bit ago, I made another video that demonstrated one of the processes you can use to make fictional data. Fictional data is useful when you need it for training, demonstration, or testing purposes. In this video, I will demonstrate using that very same fictional data in order to execute k-nearest neighbors classification. My name is Adam Ross Nelson, and I'm a data scientist. Overall, this channel is for current and aspiring data professionals who are looking to enter and level up in the field. If you think that content will be useful to you, click subscribe and hit the bell button so you will find out when there are future videos available. So in this video, we're taking fictional data that I created in another video, a previous video, and we're going to use that fictional data in order to demonstrate k-nearest neighbors classification. Here's the overall scenario. We're looking at two varieties of birds. We have the western variety of bird and we have the eastern variety of bird. Here I show how those varieties of bird differentiate themselves based on their geographic range, longitude, latitude, also their size, their weight, and their wingspan. We will use this data in order to create a prediction algorithm that will tell us whether a bird is from the eastern or the western variety. Let's go over to the code. Here we are at a Jupyter notebook. We're performing the standard imports. We're importing pandas as PD, numpy as NP, etc. The next step is to get and review the data. I have a version of the data for this particular video in the GitHub repository. Check the video comments for a link to that GitHub repository. Here I load the data with the pd.readcsv method, and then I examine its head and its tail. As we examine the head and the tail of this data, you see that there are 6 columns. There's a column for longitude, a column for latitude, a column for the weight of the bird, a column for the wingspan of the bird, a column for the feather colors of the bird, and then a column that tells us the variety of the bird, either western or eastern. In order to work with the color data, the feather color data, which is categorical, when I'm converting this categorical data to numerical, I use this one-hot encoding, and I like to use list comprehension in order to accomplish that. Here, I'm showing how to accomplish that with list comprehension. And then I'm also showing how you can get essentially the same results with the getDummies method on pandas. Here I show both ways in the notebook, which you can find in the link to this video. Now we review the results by looking at the data frame head, and we can see that for the observations with black, the isBlack indicator is a 1, while the isWhite and the isYellow indicator are both 0. For the yellow, we have a 1 on the isYellow column, but a 0 on the isBlack and isWhite column. For this algorithm, k-nearest neighbors, it is important to scale the data because we're going to be using distance measures in order to help classify the observations. It is important to standardize and scale the data when you're working with distance measures because when you have some factors which are on a very large scale, it is possible that those factors will overpower other factors which are on a much smaller scale. One of the easiest ways to standardize and scale data is to convert the data to z-scores. Converting the data to z-scores changes the scale of the z-scores to standard deviations. In order to calculate a z-score, you need the mean and you need the standard deviation. In order to repeat my results, I like to save a record of what the mean and the standard deviation were. This code here shows how to extract mean and standard deviation from the describe method for later reference. After saving for later reference a record of the mean and the standard deviation, then you can convert your features. Here we are converting the features using the apply method and also the z-score function that we imported above at the top of the notebook. There is at least one other method that you can use to convert the data to z-scores. Here in the notebook, I'm showing the code for that, and if you want to take a closer look at this code yourself and you want to use this option instead, find the notebook link in the comments of this particular video. Now that we have converted the data to z-scores, we can review those results. Here we can see output which shows z-scores instead of the original data. These z-scores tell us essentially how far away from the mean that observation was. This centers the data on 0, and then once again the scale of the data are all standardized to standard deviations. This pair plot from Seaborn shows a little bit more closely how the data is now centered on 0. After standardizing the data, the next step will be to train, test, split the data. We use sklearn to train, test, and split the data. For better or worse, this syntax can be difficult to remember. Just remember that first you want to do the x, and then you want to do the y. Then you want to do xtrain, xtest, ytrain, ytest. After all of that, use line completion and also Shift-Tab for some additional clues. Don't be afraid to check the documentation here. Getting good at this isn't about memorizing the syntax. It's about memorizing the principles and the concepts at work. After performing the train test split, we will then import the k-nearest neighbors classifier. Using the k-nearest neighbors classifier and the training data, we will fit a model, and then using the test data, we will look for new predictions. Here, we've entered predictions into the variable PRED, and we can inspect the results. We can look at the 5 first observations of PRED, and we can see the various predictions that were based on the testing data. To summarize all of the results and get an understanding of how the model performed overall, we will use the classification report and then also the confusion matrix. A cross-tabulation of the predictions and then y-test will tell us how well the predictions performed. On the diagonal from the upper left to the lower right, we see the accurate predictions, and on the diagonal from the lower left to the upper right, we see the inaccurate predictions. At first glance, looking at this confusion matrix and the cross-tabulation, we see that the model seems to have performed quite well. We can also get additional details about how well the model performed using sklearn's classification report. Let's take a closer look at this. Let's look for an optimal k. I have put optimal in quotation marks here because optimal, depending on your context, could mean a lot of different things. Here, we're going to define optimal k as the k that has the least error. In order to search for the optimal k, let's go ahead and create a list called error rates, and then let's iterate through all the k's through 1 to 60. In other words, let's retrain the model with k's 1 through 60, and let's keep track of the error rate each time we go through this for loop. After letting the for loop run, just a few more lines of code will give us a visualization of those error rates. This output isn't quite the output that we were looking for. Let's go back and take a look at the code and see where we made a mistake. It looks like I needed to add _i to this particular variable. Now that I have corrected this code, we see a visualization which tells us very quickly which k is the optimal k. 39 will be the optimal k for these data in this method. Let's go ahead and take a look at the overall results here at the optimal k. Here we are once again looking at the results from the optimal k of 39. I won't go into details on interpreting all of these results in this particular video. I'll save it for another video. If that's something that you would like for me to put together, please let me know. Leave a comment or let me know by social media. However, I will show a couple tips and tricks associated with inspecting the results. Here, I'm looking at the head of the actual data, and then I'm also looking at the predicted data. We could compare point by point the individual predictions, and we could make evaluations of the model based on this particular comparison. However, let's go ahead and make the output a little bit easier to read. Let's create a pandas data frame which gives us one column for the actual and one column for the predictions. Now we can compare that side by side. Let's go ahead and put that pandas data frame into a new variable, and then also let's create another column that will tell us more specifically whether there was a match or not a match on each of the items. This is output that will help us again evaluate the results at the individual observation level. So there it is. There's a demonstration of k-nearest neighbors using data that I created in another video. I'll put links to that other video and then also to related notebooks in the description of this video. Let me know what other videos you'd like to see. If you found value in this video, hit subscribe and also hit the bell button so you'll find out when other videos are available as well. Thank you so much for watching. I hope you had some fun. I hope you learned a little bit of something as well, and I look forward to seeing you in another video. Don't forget, you're more ready than you think you are. Hit subscribe, check out these other videos, and let's connect. I look forward to being in touch.